Hey my guinea pigs, I'm back to the lab. So as you requested, we will do a little hacking session on Nemesis 2 or Gradius 2 right, in Japanese. The goal of this session is to find out where Nemesis is detecting that there is another Konami game on the other slot, and try to patch Nemesis so it always trigger one of those Easter eggs. So let's start with the setup. So what I will do is I will use an emulator. So it's called MSX. So for that, what I did is I took the ROM image from Nemesis 2, right? The ROM image from Gallius, the other one we tried in real life, and I made myself a script as usual, right? That just start OpenMSX. In the first slot put Nemesis 2, and in the second slot put Gallius, right? Okay, it looks like it works. You can play with the arrow keys and the space bar. Okay, now let's die, and it should trigger the. Here we go. It triggers the Easter egg. So we're good. So we have a setup where we can reproduce the behavior. Now let's see how this OpenMSX debugger works. So let's start again the game. I will remove the sound from the game itself. That's annoying. So it works by having the emulator running in the background, right? And when you look at the debugger itself, you need to first connect to the emulator. Boom. There we go. There it works. So we have various like panels, right? Like classic ones for a debugger, something to dump the memory in there. Here the disassembler view, the registers, right? Those are Z80 registers. So you have A flags. Those ones with the prime thing are like backup registers, so basically it's like a context you can save right from the main ones. So usually you just care about the main ones. You have the flags right out of the instructions, and here is the stack, right, like whole stack. So one thing you need to understand is, like, let's say we pause the emulator, right? Like now if we look at the emulator, it's like just in break state, right? You have something that's called memory layout, right? So it's in this little window, and it talks about like various things. Let's explain that before, because otherwise you will not understand what I'm doing in terms of debugging. So I made a little bit of schematic here to explain to you how it works. So on the left hand side, you have the MSX memory, right? So like I was saying in my previous video, the MSX can only address 64 kilobytes, right? Like from 00, right, to FFFF, sorry. So from 0 to 65,000 and so on. But when you look, like I was saying, like if you look at the size of those ROMs, right, they are like 128 kilobytes, right? So twice the size of the addressable space for the CPU. So the creators of the MSX platform came with a trick to be able to support this. But you need to understand a little bit of vocabulary, right? So they divided the MSX addressable memory, right, into 4 spaces called page 0, 1, 2, and 3. Okay, and they added like a port, like on an I/O port, right, that tweaks the address lines, so you can address on those pages various bits of of what they call slots, right? Slots could be internal, like the RAM, for example, but also external, like those cartridge slots, like literally like physical slots. And they address that by segments, right? Segments are 2000 in X number of bytes. So if you look at it, like one page can address 2 segments, and you can do like whatever combination you want. I think, from what I understood. So when you start up the MSX, right, there is a way for the MSX to bootstrap, right? It loads the first first segment of the first slot or something, and from there you can actually do whatever you want with like some system functions to put like basically address specific segments of specific slots at specific pages, at the higher space of the page or the lower space. For example, you could say, okay, let's pick the segment 1 of the slot 0 and put it at the beginning of the page 0. Let's take segment 3, right, and put it there on the second part of the page. And you can do the same thing with slot 1, right? Like for example, in page 1, you can put like two random segments in the second page. So here we go. Now you know a little bit how it works. So let's now come to my strategy to get this infamous entry point, right? I need to know where to stop the program when it does something specific that relates to what I want to hack. So here, my entry point is going to be like at some point, right? Like let's say in slot 0 you have nemesis, in slot 1 you have Gladius, right? You have Gallius. At some point, somewhere in this cartridge, the MSX will call a function, right, that maps a slot 1 segment somehow, right? It has to happen somewhere in the cartridge. So I will start to look at that. I will start to look at what function is available, like a standard MSX function, right, is available to do this. And I found one. So I see this, right? It's called ENASLT, basically enable slot. And what it does, it switches the dedicated slot and dedicated page on perpetually, right? So basically maps what I was talking about. So basically it takes the slot ID and a page number and basically map it, right? So that's what you see there, right? Like when you look at this thing, right? You have your page and your slot and your segment, like lower, upper, lower, upper, lower, upper. Basically, that's the function that changes those mapping, like we said. And so, if I look at the instruction set to call a function, it's called, right? Let's see, it's normal, but the opcode is CD. Okay, CD, and then it's little endian, right? So it's going to be CD, lower bytes of the address, higher bytes of the address, right? So if I want to look at where this function is called, I need to search for CD 2400, right? Lower and high. So let's do this. So I have nemesis that is open there, right? And let's try to find there here, like this one, CD 2400. And you see that it happens. It is there right at the beginning of the cartridge, right? And it's only appearing there, right? So it's pretty easy, right? What I did is I went to the debugger, right? Look at the mapping. So look at the mapping there. So that it is, that's cool because it's mapped there, like the page 0 is mapped on 4000, right? So you look at 4000. Where is it? 4000, and we should be able to find this call 24 somewhere. Here we go, right? So I put a breakpoint there, right? And looking at the call, right? Here it's specified like this, right? And looking at those, I put like a conditional breakpoint. So a conditional breakpoint is there, like you add a breakpoint and then you add a condition there, right? And I tried to see if this was mapping at any point the slot 2 anywhere in the memory, right? And it didn't work. I went through all of the calls, right? He keep on changing, of course, right? While you are changing one phase of the game to another, right? But I didn't find the one where they actually map the slot 1. So I was like, okay, that's not good. But looking at the spec of this, I realized that they might have been used this one too, right? This is actually even a little bit smarter, because that reads the value of an address in another slot. So basically it does that magically without mapping anything, right? So it's even more convenient for the developer. I would be the developer, I would use that to detect if another Konami cartridge is somewhere else. So, okay, so let's find this one. This one is CD 0C00, okay? So let's go back to the cartridge itself. Deselect that, and then what did I say? CD 0C00. Okay, there is one. There is only one, so that's pretty interesting. So this instruction is in the segment. Yeah, the address like 7040. Right? So right, a little bit by trial and error, I noticed that when I break, the debugger actually points that Nemesis is always loading the extra pages on the extra segments on the page 2, right? Especially on the second part of page 2, right? So if I were to think that it is in slot 1 segment 3, right, for 7049, it means that the offset is 1D49 from the segment. That at the second part of the page 2, which starts at A, like we said, 8 plus 2 equal A in hexadecimal. Plus 1, it means that it's mapped somewhere in B something, right? So B, D, 49. Okay, let's try this one. And let's go back to the emulator and reset it. Ah, here we go. We have our call 000C. That is there. Exactly what we wanted to have. So how does it work, this call 000C? From there, right, you have in A the slot ID, right? So we should see in there, like in A, at some point, if we go through the loop of this, yeah, here we go. It looks at the other slot. So we are sure this is the when they start to look at bytes from the other cartridge. Okay, so let's look a little bit like I did like in my previous hacking attempts, right? Like when you have that, this is probably a low-level thing, right? They probably want to look at the cartridge, check a few bytes or something, loop over that, and if they match, okay, then I have this cartridge on this other slot, right? So if we look, like there is a return there, so probably this routine, like trying to get bytes, right, are called at BD46. And when I look, I say, oh, it's called there actually. I look at that, oh, it's called there too, right? And I continue like, oh, it's called there too again, oh, there again, right? And that's it, right? So we have 1, 2, 3, 4 possibilities where it starts to check out the bytes from the other slot. And when we look at this, you have the address to read on the in the register HL, right? And you see that it's every time it's changing the address, it wants to load from check basically from the other cartridge. And you look again, like I'm myself, right? I'm trying to look at the sorry, those addresses, right? So I'm trying to looking at the structure, right? And I see that it calls so it calls this subroutine, then continue onto the next one, then call if there is something, right? Otherwise, it calls again, and if I see that if there is some like a condition, right, it goes to the next one and so on. So those are chain conditions, right, with like various addresses they check, and then you see that DE, when you look at them, are various addresses that actually point to just stuff that is in there, like BD something, right? So it gets an address locally, it gets an address on the cartridge. Then B, when you look at B, you see that it is doing this instruction, right? And this is a looping instruction over this, right? Over this space. And B is the number of iterations you want to go through. So basically, now you got it. It's source, basically the signature you want to find in our code base in Nemesis. Where do you want to find it in the destination cartridge? What's the length of this signature, right? And check if it is matching. If it doesn't match, check the other one, 9, yeah. Check the next one. If otherwise, at the address F0, F5, set 1. So if one signature is matching, set 1 in that case, set 2, 3 in this other case, 2 in this one, or 0 in this one. So basically, I can guess that there are like 4 cartridges that can trigger an Easter egg, and one of those, I don't know which one actually, is the one from the one we have, the Gallius one. So I propose to set a breakpoint to every single of them, right? So this one, and this one, and we'll see which one is the one that is triggered by Gallius. At that point, we don't really care, and I can remove this one now, right? Now that we are okay. Let's continue and run this, and you see that it matches number 3. So here we go. This is probably Gallius. Let's see, what do we have? We have locally BD61, and it is 4 bytes, right? So BD61, so that's 43440749. Let's try to look at that in the Gallius cartridge. Okay, so I'm looking at my Octeta. We'll open my Gallius one, and so we said we want to look at 43, 44, 07, 49. Is that right? Huh? Again, 43, 44, 07, 49. Ha! Here we go. That matches straight the beginning of the cartridge. And do we have any other one like this? No. So here we go. Basically, it checks the beginning of the cartridge to see if this is this Gallius that is inserted. Okay, now let's try to trigger the Easter egg without the cartridge this time around, right? So let's kill the emulator. Let's start the emulator, but just with nemesis. Okay, let's reconnect. Let's reconnect the emulator. And let's see, do we still have our yeah, we still have our breakpoints, right? So we should be able to reset that. Oh wait, yeah, it never matches the one we have, right? Because it never match Gallius. So let's put back our breakpoint where they do the comparison, right? So it's BD49. Slot 1, segment 3. Okay. Then we start, continue the emulator, right? Reset this thing. There we go. So, all right. Now that we are here, when we look at the logic, right, like what we saw. Let's see where we can patch this the easiest way possible. So you see that it will go through that chain, right? So what if we aim at this instruction, this 3006, that is actually jumping over the thing we want to set at 3 there. Why not wiping this out, putting nops instead of this, right? So we never jump over. So we always go through and always set it in the Gallius mode. Let's try this. So it is BD14. Okay, BD14 means 7D14 in the ROM, like we saw. So if we go back to our ROM editor, 7D10 is there, so we are close. Okay, 3006 is there. Let's put 0000, which is nope, and save this in Nemesis 2 hacked. Okay. Now let's try to run it again. Okay, no need to connect back the debugger. Let's go straight to the game. See if it works. Okay, one player. Yep. Yes, it works. So we add the MSX in Gallius mode without the cartridge itself, with the backup thing. So now I'm curious about the other ones, right? Like, what if we change the other ones? Let's see what it does. So let's go back to our debugger, connect the debugger back, reset this thing. So we can see which one we need to patch. So we were there. So we see the 2 knobs we have there. So basically, what we can do, you see that it's you can see that actually there is 3. So CE puts 1, DE puts 3, D6 or C6. So let's change this one to the one we want to try out, right? Like, so let's try C6, for example. It means that we need to go there, find which one we were. So CBDE, right? So this one, take some notes. So D equal 3, CE equal 1, D6 equals 2, and finally C6 equal 0. So let's try with C6 to start with. Save that and see if anything happens when we start the game. Okay, I don't see anything that changed. Let's try the next one. So let's go back there. So instead of C6, we can try C. Okay, save that. Let's see what it does. I don't see anything. Neither. Okay, let's try the next one. We're at CE, so it's 1, D6 maybe. Oh, look at that! What the hell? It sends little hearts with the... It changed completely the assets of the game. Okay, so this one worked. I have no clue what this is about. What the hell? Okay, well, apparently it's playable still. Okay, so yeah, thank you, my guinea pigs. That was interesting. I never hacked anything on the AT nor the MSX, so I learned a lot in the process. Yeah, thank you for your support, right? And keep the comments flowing if you have ideas or things you need to explore with me. Thanks, and don't forget to subscribe.